So I am going through the SAP architecture. Uh, each part of the architecture slide leads to a troubleshooting scenario. Okay, pay attention. So SAP works in a three-layer architecture. Okay, one part is your desktop or the user desktop where you access, and then you connect to SAP application server. SAP application server retrieves or saves all the data in the DB server. Okay, so that's how SAP works. It's a three-layer architecture. It not only is specific to SAP, many other system uses it. This is a global um, architecture. Even our website also uses the same thing. Okay, now SAP, these two things, SAP application or the software which you install and DB can be put in the same server. So I can get a server. Inside that I can install my database. I can install my SAP application. This is called standalone system. Okay, this is called standalone system. And when user connects to a SAP system, they basically, if I give you an example, just a minute. So this is I'm opening the software. It's called SAP GUI. This software is basically um, used to connect SAP ABAP systems. I told you that ABAP systems are used to just a minute. ABAP systems are connected using the SAP GUI. So this is the software SAP GUI. I'm adding a system um, DS DS4. So this is a S4 HANA system. Let me see if it is alive or not. Instance number 00.0.90. I'm not sure whether it is alive or not. Just let me check. This is running. Instance number is 00 and IP address is 95. Okay, fine. So I will go to properties. Guys who never seen this SAP GUI, just stepping your foot into SAP world. Don't worry, I'll go into details how would you configure this. Okay, so here I double clicked it and now my system opens and I can log in into the system. Right? Maybe I don't know the password. Okay, so I logged into the system, right? So this is my desktop. A request went into the SAP application and basically SAP application reached to the DB and then it respond back to me. Okay, so all those things happening in a single server, SAP application DB. So this is called standalone system. Now, if we break down this SAP application server, you will see the SAP application server has two components. One is central instance, another is dialog instance. Okay, so these requests basically reach to the dialog instance, and then from the dialog instance, basically uh, dialog instance basically connecting to the DB, and then DB is getting this response. So that's how SAP system works. Okay, in this entire picture, this central instance does not take a play. So if you are not able to connect, you need to see whether dialog instance is up or not. If dialog instance is not up, if you need to see DB is up or not, because dialog instance cannot sustain without DB. Okay, so that's the point number one. Your user is not able to connect. Check your connectivity, network connectivity. If you are able to ping the server, then check dialog instance up or not, and then check the DB. Okay, I'll show you one by one how would you do that. But let's go through the basic building block. Okay, so we see that our SAP system installed in a single server, right? In standalone system. So there must be a place where this is installed, right? So this is the place. If you are a Windows installed in a Windows system, then there is a drive. Inside the drive, USR SAP SID, and if it is a Linux system, USR SAP SID. So you can confirm from right here. Let me just pull up 192.168.0.95. Okay, so if I go to this location USR SAP US, USR SAP, and I'll show you the directory content. Here I see that these folders, right? DS4 HD. So in the first slide, you remember that we have seen that system ID is 3 character. It has to be start with a letter. That means this is a system. This is a system. Two systems are installed here. I don't know what it is. That can be seen later. But one thing is clear. Inside USR SAP, you have system ID. I have system ID DS4. I have system ID HDT. So that means two systems are installed here. Two SAP systems are installed here. Okay. Now let's go into the DS4 system. So if I go to DS4 and type ls minus l, here you can see that four folders are there. These ACS01 and D01, these are called instance folder. Now this is dialog instance. This is central instance. If you see this picture, you will see that SAP system is basically divided into two building blocks. One is the dialog instance, another is central instance. So these are basically two, the central instance and dialog instance. Central instance always start with ACS, then a number. This number is called instance number. This number is defined during the installation. We'll see when we install S4 HANA system how would you define the instance number. And dialog instance is called start with D. Okay, and it in some system it starts with DVMG something like that. But in more modern systems, you will see that it starts with D, then the instance number. Okay, so here same thing you can see that your SAP system basically comprised of two building block. One is central instance and dialog instance. Okay, all right. So that's the very basic of it. Now, if we further break it down, you've seen that dialog instance and central instance how it works. Now, placing the files in the operating system. Right now, we have seen that there are some folders in the operating system, but placing files in the operating system does not make a system, right? You need to run some process or run some executable to have that service available for the users, right? So these are the service. Dialog instance has four service. Okay, one is called disk plus work, another is called IGS, ICM, and gateway. Four services in dialog instance, mandatory services. In central instance, you have two services. One is message server and NQ server. These all six services has their own work. So what they do, disk plus work basically do all the work. Okay, whatever user request basically computed and calculated and returned back to the user by disk plus work. No other process. IGS basically responsible for generating graphics. ICM is generating for web traffics. Whatever traffic comes from the user on HTTP protocol or using the browser, it handled by ICM, and gateway is basically responsible for RFC communication. That means system to system communication. Now, if you are paying attention whatever I'm saying, it troubleshooting information hidden inside it. Why? Because if your user not able to connect to system, if your user is not able to compute anything, where you do check? You check your displus is working or not. If your user able to log in but not able to generate the graphics in the system, you check your IGS is working or not. If your user is not able to connect to system using web browser, you check your ICM is properly configured or not. If your system is not able to communicate with others, you check your gateway process is running or not. So troubleshooting is embedded into the architecture. The more, I mean, the more clarity you have in your architectural understanding, the more better troubleshooter you are. Okay. Similarly, the central instance also have two important components. One is message server, another is NQ server. What are the significance of it? Message server is the brain of entire system. What it does, it keeps track of the all processes and resources. How many instance you have? You have one dialog instance, one central instance. This message server has this information, right? And how much loaded this dialog instance, how much it is working, if it is freely just sitting ideal or it is loaded with work, right? This kind of information a message server holds. What is the significance of this information? We'll see later in the distributed system step, but right now keep in mind that message server is like brain. It keeps track of the all things in the SAP system, how many of them, what are they doing, this kind of. What NQ server does, it keeps track of the logs. What are the logs? If I am editing information or I am juggling with information, so I am connected to dispatcher work, dispatcher connected to the DB, and I am editing a data. The same data cannot be edited by other, right? Because I am changing already. In the meantime, somebody changes. It will create a conflict, right? So then what happens? NQ server keeps that log that this data is being changed by someone. So nobody else should edit that data. Let's see how it works. Okay, how it works in real life. So apart from these processes, these plus work basically it calls ABAP dispatcher. ABAP, apart from these plus work processes, there are some other work processes which does actual work. So let's see how it works. So user request information, maybe a thing or any request. So it goes to the dis plus work. Now dis plus work sees first it checks what kind of request it is. If it is a request which user is asking some data directly from the database and calculating and then provide it back, or if it is asking to print something, if it is asking to update something in the database, this is checked by the ABAP dispatcher. So let's say user is asking to compute some data, or it is asking a result of a transaction or something. What will happen? It will simply assign a dialog work process. We will see all those things in the system in real life. Okay, and then before it provides all the data to user, it consults the NQ server that my user is asking this data. Can I provide this data? If the data is already being edited by someone, NQ server will simply reject it. It will say no, this data already being occupied by someone, you cannot do it. So then it will simply throw an error. Okay, but if it is successful, then dialog work process directly get the data, calculate, compute the data, and get back to the user. So that's the entire life cycle. Now, again, this entire process holds a very significant information about the troubleshooting. Okay, so if you see that your user is complaining that I'm trying to edit a data but it's saying lock, that means where we need to see the NQ server logs, that if the data is locked by someone or not. So I say again and again, these few slides and these few concepts, the more it gets into your mind, the more better troubleshooter you become. Okay, what happens if all the work processes are busy? That's why we have dispatcher queue. Okay, so if anything comes, um, all the work processes are busy, then this above dispatcher will basically puts the request to the dispatcher queue, and once this is free, again it assigns a work process. So that's how the standalone system works. And again I say that this is the single most important thing in SAP administration. If you understood this, you should be able to do all 90% of troubleshooting. If you are having a problem with your user executing a transaction, if you are having a problem, where you will see the dis plus work log in the work directory. If you are having a RFC, where you will see maybe gw.rd log or the RFC log in. We'll show. I'm just giving you an example. I'll show you all those things in real life with troubleshooting scenario. Okay. So in a nutshell, when user request, it goes to ABAP dispatcher. ABAP dispatcher nothing but a dis plus work process, and this ABAP dispatcher assigns based on the request, assigns a work process. Work process again nothing but a dis plus work exe itself. Okay, some dis plus work exe work as a dialog instance, some dis plus work as a background, some dis plus work as a, so same exe but it works as a different process. Okay, now uh, now um, what I was thinking, yeah. So I'll show you this in the system, where to see how do you see this plus work and everything. But this is the core architecture. Goes to above dispatcher. Above dispatcher assigns a work process. Before getting the data, it reaches NQ server, saying, checking if it is locked or not. If not locked, get the data, calculate, respond back. If this is locked, then don't get the data, just respond back this is locked. And that is the architecture of the standalone system. Okay, all right. Now, you can have multiple dialog instance. So inside here, if you see that we have only one dialog instance, during the installation I can have multiple dialog instance. We will see in the installation topic that how can you install additional application server or application instance. This is possible. Okay, just for reference, just keep this in mind. We'll see this later. Okay, in that case, you can directly connect to dialog instance 1 or dialog instance 2 as per your choice. So if you see my SAP GUI, uh, where is SAP GUI? Yeah, in my SAP GUI I have mentioned instance 00. Okay, why? Because my dialog instance number is 00, and in my um, uh, document also, what I have shown, that the user connects to the dialog instance. So that's why in system you see that my dialog instance is 00. So that's why in the GUI also I have mentioned that I want to connect to 00. If I mention here 01, will it work? It will simply not work, because ACS is not able to handle the dialog request. Okay. All right. So as I told you that yes, you can have multiple dialog instance, and user can connect based on the GUI entry. They can mention 0102. They will connect that dialog instance. Okay, uh, and rest of the things pretty much happen similar way. But this is not the proper way, because uh, if you are mentioning dialog in 01 in your recipe GUI, you will always connect to 01. Uh, if you mention 02, you will always connect to 02. But what happens if 02 is not working at all? I mean, if it is down, then what happens? Then you will see a error that system is not available. But at least dialog instance 1 is available, right? So then it is not proper use of the system. And also, if dialog instance 1 is heavily loaded and it is not loaded that much, so then also your request, if you mention 01, the request goes to 01. This is incorrect. So that's why we have a concept called message server load balancing. You remember in above topic I told you that the message server in the central instance, you have message server. This message server keeps track of the all things here, how many dialog instance you have, how many work process you have, everything. Now that will come into the picture. Okay, so in this case what happens usually, what used to be happen that we'll be connecting direct to the dialog instance, and dialog instance is doing all the stuff. But in this case what will happen, user will be connecting to the central instance. And what central instance do? Central instance has all the information, right? How many dialog instance I have, if those dialog instance up and running, are which one is more loaded, which one is free, all those information in central instance have, especially the message server of the central instance has. So based on that information, it will redirect to the request to dialog instance, and then from then it will happen as usual. Whatever you saw in the standalone, it will happen exactly similar like that. So, but these, which one is free, which one is alive, that part, that load balancing is being done by the message server process of the central instance. Okay. All right. Now these all we were talking about the standalone server. Now let's talk about the distributed server. So we in previous slides we see that the SAP application and database can be put together in a single server. But what happens if we put two things in two different server? Install SAP application here and install database here. Does it call distributed system? The answer is no. When you talk about distributed system, it does not refer to the database or a database, and it does not mean the uh, relation between database and application. Here database and application in separate server, but still it will be called standalone system. When you install using SWPM, you will see that for this scenario you will choose standalone scenario. Why? Because when we talk about distributed, we talk about SAP application distributed system. Okay, it's talking about SAP application, it's not talking about database. Okay, so this scenario, SAP application in one server, database in another server, still it's a standalone system. It is an interview question. People ask, interviewer ask that I have one server, I have database in one server, application in another server, is it a distributed system? Answer is no, it is not a distributed system. In SAP perspective, when you talk about distributed system, it's about having distributed application. In this scenario, application is not distributed. Then what is distributed application? The distributed application would be this. Here in this scenario, I have three servers. One server we have central instance. In another server we have dialog instance. We have in another server we have DB system. Now keep in mind that we call it distributed system not because of DB, only because we have the central instance and dialog instance in two different server. That's why we call it distributed system. Okay, and we can have one more server uh, for one more dialog instance or one more application server. One more time, guys, please don't be confused. I'm just running over the topic just because I want to give you an idea about the architecture. We will be doing all those things hands on, and we'll be coming back to these slides and we'll be clarifying by hands on. Please don't get confused. I just want to run it over so that we have a reference whenever we are starting a topic hands on. It should not be the case that we don't know anything about it. This is the only class which is entirely theoretical. From next day onwards we do practical and we refer back to the specific part of the theory and we revisit that. Okay. All right, so this is the distributed system. uh, Basically, that concept which I was talking about, that your message server has all the information. So, what kind of information the message server has? First, look at this picture. You have four server. In one server, you have DB. In one server, you have dialog instance one, dialog instance two. In another server, you have dialog instance three, dialog instance four. In another server, you have central instance, and in central instance, you have two things running, right? One is NQ server, which is keeping your log. Another is message server, which has the information about all the system. What information? That how many application server we have, how many dialog instance we have, are they are up and live, how many load they have. This information. It basically keeps a table, like it maintains a table like that. Okay. I have so message server will have a table where it will write that I have a application server 01 where I have dialog instance 01. In the same application server, I have dialog instance 02. I have another application server which is SAP App 02 where I have dialog instance 3. I have another application server which have dialog instance 3. Now, if any request comes, it will simply go to the table and it will say that in four application server, what are the application server is up and running, and on those up and running server which has less load. Okay, and it will simply forward the load to that application server. That that is the work of the message server. That is called load balancing. That's how distributed system works. That's how it makes sure that all the resources has optimized utilization, so that if any of these resources goes down, message server will see that my these resources is gone down. Now I will not forward the request to this, so it will forward to only these instances, so your user does not notices that there are servers which is down in the system. That's how distributed system works.